Hello students, today in the section database management system, we will discuss various constraints we implement on tables. So, constraints are useful in various ways. So, but topic is the data integrity and constraint. Why data integrity is needed? Data integrity refers to maintaining and assuring the accuracy and consistency of data over its entire life cycle. So, all the records should be accurate in database. So, this can be ensured using the constraints, various constraints we use to implement on the database. Database system ensures data integrity through constraints which are used to restrict data that can be entered or modified in the database. If we are going to modify anything, so there should be some constraint so that we should not update any wrong information or invalid data into the tables. In DBMS, constraints are the set of rules that ensures that when an authorized person or a user modify the database, that do not disturb the data consistency, and the constraints are specified within the DDL commands like alter and create command. We used to update the database using alter command or the create command. Database system offers three types of integrity constraints. So, mainly these three types of constraint we will discuss. First one is the entity integrity, domain integrity, referential integrity, entity, domain and referential. So, in entity integrity, each table must have a column or a set of columns through which we can uniquely identify a row. We should identify a row uniquely. So, for that entity integrity is used. These columns cannot have empty values. So, mainly this can be implemented using primary key. This enforced through primary key. Domain integrity. All the attributes in a table must have a defined domain, that is a finished set of values which have to be used when we assign a data type to a column. We limit the values that it can contain. In addition, we can also have value restriction as per business rules, like in example the data should be male or female, then we can use check constraint for that. Data types, which data type values will be inserted in that column, and check constraint like in gender case. Referential integrity, each value of a column in a table must exist as a value of another column in a different table. Like two tables are given, and if we want to get the data in the another table from the main table or the parent table, all the values present in the parent table should only be come in the the child table. So, that can be implemented using referential integrity. We heard of the name foreign key. This is enforced using foreign key. So, various constraints are implemented on various rows and columns. So, the domain integrity implemented on columns and the entity integrity implemented on rows, and the referential integrity are implemented or enforced using in two tables. Domain constraint. So, first thing we will discuss the domain constraint. Domain constraints are user defined columns that help the user to enter the value according to the data types. So, what data type we have given, that data type value will be inserted in the particular column, and if it encounters a wrong input, it gives the message to the user that the column is not fulfilled properly. Means if we insert wrong information, it will give you the error message like the data is invalid or it cannot be inserted. Okay, or in other words, it is an attribute that specifies all the possible values that the attribute can hold. Like If a value can be integer, it will hold only integer value, character, date, time, string, etc. Any type of data type that can be inserted into the particular column. It defines the domain, mainly it defines the domain or the set of values, for an attribute, and ensures that the value taken by the attribute must be an atomic value. The atomic value should be only be inserted, as it is a constraint, like domain should have only single value in the cell from its domain. So what we got is the domain constraint. Domain constraint will be implemented for the data types like integer, character, date, time, string, etc. We can use any other data type also, plus the constraint, like if we want to implement this data type, integer data type, and it should not be null, we have to give all the integers value, or it should be unique, means not be repeated. Primary key, it should not have null as well as cannot have duplicate values. Foreign key, in the domain itself, we can use foreign key, means all the values that will be inserted should contain in the primary key, primary table. Check constraint or the default value, we can set the default value also. Type of domain constraints. Type of domain constraints, they are in the domain constraint itself, we can have various types. So there are two types of constraint that come under domain constraint, and they are, first one is the not null type. Not null type, not null values, the null values are the values that are unassigned. If we do not want to insert anything, that means it is a null value, we do not want to insert anything. Or we can say that which can unknown, if the value we are not knowing, like you have to insert the Aadhaar number and the Aadhaar number is not being generated, or you have forgotten the Aadhaar number, then you will update their null value. So, or the missing attribute values by default, a column can hold the null values, all the columns can hold null values, but we can add constraint to it that this particular column should not contain any null value. So not null constraint will be used. Non null can only be applied on the column label constraint. This point is very important, that not null can only be applied as a column label constraint. Not null constraint restricts a column to not accept the null values, which means it only restricts a column to not restricts a field to always contains a value, which means you cannot insert a new record or update a record without adding a value into the field. So all the values will be complete in that particular column. Like we have example, let us create not null constraint on student ID and first name column. So here are the syntax: create table student, where student ID is a data type integer and it has some constraints on student ID that should be not null. First name data type is varchar and it should also be not null, and the last name is data type is varchar. So three attributes are there in the student table, where all the data types are given and the constraint is also given. Constraint, writing the constraint is not a mandatory thing, you can also skip that part. So we have the example, us we want to try those, we want to insert those values into the table. Then we got what we got, we want to insert 1001, it's a number, and the first name is null and the last name is Ferguson. So in this particular example, it will give you a error message, it will throw a error message showing that you cannot, the insert failed as first name values was null, you cannot null that value. The null constraint will come into effect, not null constraint will come into effect. So, a valid record of the type is, if we insert 1001 Alex and Ferguson, it will be inserted, one row is created and the details are shown here, and we get a message the record was successfully inserted. If a space is a valid thing, if we insert a space, then it will consider as a not null value, means we have inserted something. So, in this case we want to insert 1002 and a space, it is a text message, and in this text some value is also given. Here also one row is created, like we have these two information before, and this one information is also being inserted, as a space is not treated as null and is successfully inserted into the database or the table. Empty string, if we want to insert a empty string, it will throw an error. So, if you want to insert 1003 and a empty string, here though no space is also given. So, and the other details on the third attribute we will get Ferguson. So, this entry will not be inserted, or mainly Oracle treats empty string as null value, hence record could not be inserted. Or you can retry other examples to check that. Now, the second thing is the domain constraint. It defines a condition that each row must satisfy, which means it must satisfy some conditions. So, which means it restricts the value of a column between ranges, or we can say that it is just a condition or a filtering checking before saving data into a column. We want to save something and we do not want other thing to be inserted, it's a default value should be like this, then we should use check constraint. It ensures that when a table is inserted inside the relation, it must satisfy the predicates given in the check clause. So, we have already been given some type of values, that only these values will be inserted into the column. Let us check constraint on gender column to only allow male or female values, F or M values. So, in this particular table we have given check statements, like student table is generated and it is having student ID as an integer value and the first name as a string value, varchar type, gender should be of character 1 and it has having some constraint on student gender. Check is the constraint where gender in male or female. So, if we want to insert, only two values will be inserted in particular column, like M and F. We will check this as valid record will be 1002 Alex M. This is a valid record, and if we run this query, it will execute it and one row is created into it. Like here we can say this value is inserted, the record is successfully inserted into the table. So, what are the type of invalid records? Let us try to insert a record which contains values that violates the check constraints, like 1001 Alex and the X, as X is not mentioned in the check valid values. So, it will throw an error, the check constraint violation is there. Okay. Insertion failed as gender value is neither M or F. Okay. Key constraint or the uniqueness constraint. These are called the uniqueness constraint, since it ensures that every tuple in the relation should be unique. A relation can have multiple keys, so it can be enforced during keys or candidate keys. Candidate keys are the minimum super keys, out of which we can choose one of the keys as primary key, and we don't have any restrictions on choosing the primary key out of candidate keys, but it is suggested to go with the candidate key with less number of attributes. We can choose any type of attribute, it can be used as a candidate key. So, minimal set is required so that it can uniquely describe the table. Null values are not allowed in the primary key, and not null constraint is also a part of key constraint. This is important point. Null values are not allowed in the primary keys. So, it is also null constraint is also a part of key constraint. Okay. So, we come through some example. Example are mainly there are 3 attributes given: EID, name, phone, and we have values 01, 02 and 01, because Paul, Tuhin, and the phone numbers are given. In the above table, EID is a primary key. So, this is invalid set. We cannot have this type of values in the table if we implement constraint that key constraint is implemented. So, it violates the key constraint. EID is the primary key and the first and the last tuple has the same value, that is 01. So, it is violating the key constraint. Primary key constraint on a column ensures that the column cannot contain null and duplicate values. If we enforce primary key constraint, then we cannot have null values and the duplicate values. Null values and the duplicate values. We can have only one primary key in a table. This is also important. So, we cannot have various multiple primary keys implemented on the table, like we constrain this is also primary key and this is also primary key. That is not a valid way. So, we will now create a student table with primary key constraint on student ID. So, student ID will be treated as a primary key. Here the table is created, student table, create table student with a integer, it is an integer data type, and the constraint is primary key. First name is simple, no constraint is given, and contact there is no constraint is given. Let us see. So, what are the valid records? Valid record 101 max and the details are given. As first time any value can be inserted, but it should not be a null value, as primary key constraint is given. So, it will be inserted successfully. Okay. Next is the valid, it is a record, valid record 2, we insert this and this will also be inserted, as it is distinct from this is distinct value. So, record is successfully inserted. So, if we want to insert any null value, like in the student ID column, we try to insert null value. First name and the phone number is a valid data, but if we try to run this query, it will throw a error, cannot insert null into student, because the insert failed, because the student ID cannot be null. So, if we want to insert duplicate record here, like 101 as already being inserted before, this cannot be inserted again. So, this is violation of unique constraint. Okay. So, the insertion failed because the student ID is a duplicate value. So, this is also through an error message. So, more about entity integrity constraint. We have discussed key constraint, now the entity integrity constraint. Entity integrity constraint says no primary can take null value, mainly null value is the prime concern. Since using primary key we can identify each. So, in the above relation, EID, employee ID is made a primary key and the primary key can't take null values, but in the third tuple the primary key is null. So, it is violating the entity integrity constraint. So, key constraint can do the entity integrity constraints job also. Referential integrity constraint. The referential integrity constraint is mainly specified between two relation or tables and are used to maintain the consistency among the tables in two relation. So, we want to get a table that will be inserted from the other table, a child table being created from the parent table. So, all the details which particular column or a particular two or more columns in a child table will be inserted from the parent table. So, it contains all the data from the parent table only. We cannot have distinct data. As a child, it contains all the properties of their parents. Same is done here in the referential integrity constraint. If we want to reference something, all the data come from that table only. No other values will be inserted. Duplicate values can be inserted. This constraint is enforced using foreign key. We use foreign key to implement this constraint. When an attribute in the foreign key of a relation R1 has the same domain, and it should have the same domain as the primary key of relation R2, then the foreign key of R1 is set to reference or refer the primary key of relation R2. Okay. The values of the foreign key in a tuple of relation R1 can either take the values of the primary key of some tuple in a relation R2 or can take null values, but can't be empty. Okay. So, let us see it from example. Here in EID, name and department number 1, 2, 4, this is the main table and department number is the child table. In the above relation, department number of the first relation is the foreign key and the department number in the second relation is the primary key. So, this is a child table and this is a parent table. Okay. So, this all the data will come from this table. 13 cannot be there, 14 is there. So, this is the value, this is a wrong value that should not be added. Okay. It will throw an exception. Like in the above, department number of the first relation is the foreign key and department number in the second relation is the primary key. So, department number 22 is the foreign key of the first table is not allowed since department number 22 is not defined in the primary key of the second relation. Okay. So, this value, this is the primary key, okay, here, and this is referencing. So, this value is not given here, 13 value will be inserted, this is the child here and this is the parent here. Okay. This is the child and this is the parent, and this 22 values are not allowed since department number 22 is not defined in the primary key of the second relation. Therefore, referential integrity constraint is violated here. Okay. Student table has already been created and inserted with few records in the database. Let us now create a table marks with marks stored by each student in each course. Like create table marks, course ID integer, student ID integer and the marks scored is decimal. So, we have course ID, student ID and marks scored. Already data being stored, already data being inserted. So, the insertion here fails because this ID, mainly this ID is not a valid ID. Foreign key, more about the foreign key. Foreign key is a set of one or more columns in the child table whose values are required to match with the corresponding columns in the parent table. So, foreign key establishes a relation between these two tables. Mainly, we have a computer table and a employee table. So, this is the these two tables are given. This is the child table, okay, referencing table, and this is the parent table. Okay, here it is a parent table. The child table contains null values. The child table can contain null values. Let us make an example of the employee and the computer table as below. Okay, this is the parent table for this particular child table. So all the it contains computer ID 101. So this is referencing it 102. So 103 as in a computer table, this is the primary key and this is the primary key, and only these values will be inserted into this table as it is a referencing table. Okay, so we have a problem here. We can insert null here, but only these values will be inserted. Computer is the parent table with computer ID as the primary key, and employee is the child table with ID as the primary key. If we need to assign a limit of one computer to an employee, then computer ID should be made the foreign key in the employee table. So if you want to assign only one computer, multiple computers should not be given to any employee. Then we can use this foreign key constraint. It can just contain values that are available in computer table, that is in computer ID column, and no values at all, null, depends on the constraint type. So 1-to-1 constraint is there, then null values should not be added. We cannot allocate a computer that does not exist in an employee. So if a computer is not available, how can you assign those computer to a employee? So if it is not existed, then it cannot be inserted to the employee table. Additionally, numerous rows in the child table can connect to the same row of the parent table depending upon the type of relationship. So it depends on the relationship. If 1-to-1 relationship is there, only one computer will be allotted to the employee. If the constraint is, if the relationship is one to many, then many computers will be inserted. So to summarize all the constraints that we have discussed today, so here two tables are given: create table student, here constraint student ID, integer type, first name, last name, gender, date of joining, contact number, person ID, and the constraints are given. So all the column level constraints are shown by this C, constraint, column level constraint. This will be added to the column level. Not null, not null, not null, null is a column level constraint only. We have, but in the table level constraint, check constraint can be implemented using table label. Another constraint also, that is primary key constraint, check constraint, foreign key constraint. These are added in a table level. All constraints need not to be provided a name. This constraint should not be given any name, one type. And 2 is the composite constraint, can only be specified at table level constraint. Constraint that composite constraints are only be given at table level, and not null can only be specified at column level constraint. These are the few points that to be summarized. Thank you everyone.